Hello, everyone. You're welcome back again. And in today's episode, we'll be looking at how to make use of the Pandas package in Python for sort of manipulating a time series. Now, you might have a data in a certain format, which is very, very critical when it comes to, I think, most operational meteorological centers use that kind of data format. And when you get the data in its default, you want to sort of stack the whole data so that it becomes just a two-column data of time series and then the data itself. All right, so without wasting my time, we'll delve into it. And then I believe that while I work on it, you would also get to understand what we're talking about properly. And I hope you also try your hands on it. So we're making use of the pandas package. So we try to import pandas here as PD, right? And then if we need any other packages, we'll also pack them here. I believe we would also need the path from the path lib. So from path lib, that's from the path library, import path. And what this does is to help us easily move through directories or change paths like we would basically do as we were on the terminal, or let's say the console. Yeah, right. So now this is where my data is. If I step back from the notebooks into data, yeah, I have data sets over here. I'm making use of this test RR data. So let me copy the name from here. All right. Okay. We can go back. Okay. So our file name is in the path. Now, if I go back here and then I check my present working directory, it is in the notebooks, but I don't want to move. I want to move back into this, say, the previous folder, and then from there be able to access the data folder. All right. So we move in here, dot dot, which is to go back, and then later to step into the data. And then this is the file name. All right. So that's the file name. Now, there's an Excel file. So there's a sub package of pandas or a method of pandas called read Excel, which allows you to read certain files in Excel. So I have in here pd.read Excel, and then I call the file name. And then there should be, so if you check in the PD read Excel documentation, when I just hit Shift Tab, it produces this, so I can know what items to keep in there. I need the sheet name because an Excel file would have different sheets. I believe the sheet name in this should be the respective RRT and then NTX. So let me make use of the TN, for instance, okay, and pass this as my data. All right, but this is going to be a data frame. So because it contains different columns of, different rows of particular stations, and then, other columns of other information. So yeah, and then just so you understand, the data series is just like a single column data, and then having multiple column data together is a data frame, and that's how pandas treats tabular data. All right, so I hope, okay, I think the sheet name is wrong, so let me quickly just check for the sheet name. All right. So I think I entered the wrong name. The sheet name should be TN as in uppercase T and a lowercase n. All right, and that works. Now we can actually see what the data contains by passing in DF data, and probably with the head to see just the first few rows. Okay, so let's say we want the first 7 rows. Okay. Okay, so this is what the data contains. So there's the station name, there's abbreviation for the parameter of interest, the year, the month, and the daily data for each month and within each year is actually stacked as horizontal. So you have val01 representing day 1, val02 representing day 2, day 3, on and on, in that same order. Okay, so what we want to do first is, in this case, because we will be stacking the year, month, and the day together. So I would have a time series like 2010, 01, 01. Now I want to replace the val 01s or val 02s into their respective day numbers. Okay, so I could comment this so we have fresh panel to work with. Okay, so we pass in, let's see first what the columns contain. So df underscore data dot columns. Okay, so this column 0, column 1, Python indexing starts from 0. So column 0 is the name, 1, 2, 3, and then 4. So runs from column 4 all the way to the end, which just produces this. All right, so let me try assigning it back to a range of numbers. Say 1 to 32. So that starts from 1 to 31. All right. Now that produces an error. So index does not support mutable operations. Okay, so what we want to do is to rather change not the columns themselves, but the values contained within the column. All right, so I believe this works. Okay, so now if we go back to our df underscore data, we look at the head. So the first 2 rows. Okay, so now we see that the headers of the val 01, val 02, and so on and so forth have been changed to their respective day numbers. Okay, and this starts all the way to day 31. And you can notice, say in particular month, say February, for instance, there are nuns in the end. So just to allow us to know that, okay, day or that month probably has less than 31 days. But then they will just stack them in this way. Pandas has the ability of dealing with, missing data easily. All right. So now, after seeing how the data structure is, which I believe, let me keep that back. After seeing how the data structure is, what we want to do is to sort of change this data structure to have more sort of vertically placed data, which probably contains the name and then probably a parameter if you want, and then the year, month, and time. The year, month, and day stacked together as one time, and then the value on the other side. And so to do that, there's a component or a method in Pandas called pd.melt. So there's a melt function in Pandas which allows us to do that. And in melting, we actually have to set our ID vars, which is the positions to maintain while melting the other components of the data. All right, so we're going to pass in this as a list. So let me quickly get this part. So pf underscore data dot columns, and then go on column. Okay. All right, so I just can get hold of these names and then pass them in here. All right. Now, after passing those names in there as the components to maintain, Now we can also set the variable name, which is after stacking all the year, month, and the day together. We probably would want even the month also to be preserved. The only thing we want to do is to also have the day data as, the day information as another column on its side while stacking the data on its side. So what we are going to do is to set the var name to the parameter day. So that produces a day column, right? Which would be with the headers up here. Okay, so let's call this df data. Let's say melted. Equate that to it. Right. So I had, oh, sorry. Yeah. So even though it's from the Pandas data frame, the Pandas package, we're running this on a particular data frame. So we call the df data, which is a data frame that we are melting. And then we employ the melt function on it and pass in these arguments. And then that creates a melted data for us. So if we check back our df data underscore melted, let's see here. Let's pass in maybe the first 10. All right. So now it sort of stacks the data up for us. So we have the name, the abbreviation, the year, the month, and then the day, and also the value. Now, what we notice from here is that the day is sort of arranged in um, ascending order. So instead of it having maybe year, month, and then the day, maybe 2010, January 1st, 2010, January 2nd, rather, it's sort of sorted by the day. Okay, so all the ones appear before the others. But then this wouldn't be an issue because, well, we are going to make this a time series, so it becomes easy to just work with that. Okay, so now that we are sure of what we are getting, I think we could skip this part out. Okay. All right. Now the next is to change the year, month, and then the day into a time series. Okay, so that's quite easy to work around. Okay, so we try in this case to change this to a time series. All right, so I think we are having this error. One of the things we needed to do was to drop the missing times. So we dropped NA. Now the reason being that there are some times, for instance, we would have, if I look at the data set, I'll definitely have, because I was just melting them, I'll definitely have dates like, for instance, 30th February, I would have like 31st February, but then those are not correct time. So there are two ways of doing with that. Now this in the data they contain none, so I can just drop the none and that would work. That's because no other part of the data contains none. But then you could also coerce the time. So there's a coerce function which you pass through, and then that would then give you NAT for those times, which are definitely not going to be time series. But then you can then use that function, to get NATs for those wrong times, and then omit the wrong times from your time list or your data series of time. Okay, so now that we have that, it means after dropping, and we run time series again, trying to create the data, trying to create the date from the year, month, and day from actually DF data, which we melted. That should work. Okay. And so now our DF data, that's for melted, contains, the date. Now after doing this, we can equally, after passing this, we could equally just drop. So we have DF underscore data underscore melted. You assign it to back the same DF. And what we want is we can just drop, or we can actually call the ones we need. For instance, I need here the name. I need also the date. And then I need here also the value. Sorry. Yep. So that works. So now we look at the melted, and then it contains the ones we only extracted, which is the name, the date, and then the value. Okay, so another thing we can do is to set the date as our time series. And also not forgetting that the name contains multiple stages. So we want to have the time as the index for all of them while we have the various names as separate rows. So we can then use the pivot function, right? We can set the pivot function on this to set our data as the index and then pivot the names or create different rows for each station. All right, so to do that, we call our df data, which we melted. And first, we want to set the time as our index. So set index, and then we pass the date in there as our index. And so this is what produces the date for us. Okay. So we still have the date as our index and then the name and then the value. All right. So this should equally work with the time series and make it quite easier for us. Or what we also want to do, in some cases, maybe you want to sort before you set the index so that it would be in the same sort of the order in which you want it to increase, 2010 01 01, 2010 01 02. I think you can try the sort function and we sort by the dates first. Okay, there's an error. DataFrame has no attributes. Okay. Let me try this. Okay. Oh, yeah, sure. Okay. Yeah. Okay, so try the sort. Okay, so try the sort values. So at this point, we've not set the index yet, so we wouldn't use a sort index. So we rather sort the values, but you can also do it in the other way, where you set the index and then sort by the index. So I'm sorting by the values of dates first before I set the index. All right, and so this produces it in the same order that we want. So you have 2010 0101 for Tamale, for Kumasi, for Tema, and then it moves on to day 2. You get it the way we want it to be. All right, so now that we've set the index, you can notice from here that we have about 3 stations for each particular date. Okay, but what we want to do is to have each of the stations as a separate column. So what we are going to do is to apply the pivot function. And so I could assign this whole thing to a variable and then just do the pivoting to make it easy. Or I could just add in here dot pivot. All right. And in the pivot, you need to indicate at least some basic things, the column name, and then also your the values. And the values are these are the values that will be splitting. Okay. And the column names you want to the headers you want to be for each of the columns, which will be from this name. Will be one for maybe Taman, one for Kumasi, one for Taman. So it's going to pivot around these 3 locations in here. Okay, so we can then pass in here column name. Let's pass in the name, and then values equals to value. Okay. Okay, it should be column names, right? I believe. Right. Okay, I'm skipping out something. Okay, so let's make this easier. Let's call this df underscore data indexed. Okay, and then crop the side out. Okay, so okay, so we have df underscore data indexed dot pivot. Okay, all right. So it should have columns, not column name. So columns equals to the column name, and then the values equals to value. That's it. And you notice that the data has been sorted or sort of pivoted around the index of the datetime and then arrange the data in the order that we have it. Okay, so with this, it's quite easy then to visualize the data set. So let's reassign this to say df data pivots. Okay, so we can just quickly visualize our data set. You can have df underscore data underscore pivot dot plot. It is just working with the same matplotlib packages just to create a simple visualization of our data. And okay, now I needed to pass in here percentage matplotlib inline, just so that this feature allows the plots to show directly in the same Jupyter notebook or the Jupyter Lab cells. Now, if I don't do that, you notice that it tells me, okay, we are creating a plot. However, the method or the function is shown, but then nothing is produced. So with that, now we have an output. And there's like a quick way of visualizing your data. All right, so the emphasis of this training or this particular tutorial was on how to sort of melt the data, melting the data frame so that it becomes more like a stacked data, and then we can then sort it along the values and then set the data index, and finally pivot the data if there are similarities. For instance, in this case, the data was pivoted around the 3 different locations because all the 3 locations contain some data, and so we then melted, we sorted, and then we also pivoted, and we had the data in a format that it's easy to work with, which is in this format. So the final thing we had is df underscore data underscore pivot. We can check the first 5 lines. And that's quite easy because we have our time series, we have the time or the dates on the as the index, we have the data, the respective data aligned to them. And there's more easy and more friendly to work with than what we originally had, which was from df data. All right, so it's been fun running you through this. I hope you would find this friendly and very useful in your day-to-day work, especially operational meteorologists who make use, people in the operational centers who work with such data sets and then try to perform some analysis with it. I believe you had a wonderful time. If you have any question, don't forget to leave them in the comment section, and then the team would try as much as possible to address them. I wish you all the best in the Python journey, and I hope that you'd find it very smooth despite the odds. Okay, see you on the next episode. If you are new here, don't forget to subscribe, like, and then share this with friends and people in your network so we learn and build together as a community. Thank you. Bye-bye.